Okay, so this is how to do Kc expressions with units for heterogeneous equilibria. So what is a heterogeneous equilibria? It's one where each of your chemicals does not share the same state symbol. So for example, S8 here is a solid, whereas my other chemicals are gases. Now there's three things to bear in mind here. The first one is when you're doing your Kc expression, we should not include any solids in that expression. So the Kc expression for this equilibria would be SO2 gas to the 8 over O2 gas to the 8. Not including the S8 because the S8 is a solid. Now, why is it we don't include solids in our Kc expression? Ultimately, it's because their concentration is going to remain pretty much constant. So let's have a look at that. Concentration is moles per decimeter cubed. So it's the number of moles in a decimeter cubed. So let's say this pink box I'm about to draw is a decimeter cubed. However many moles are in that, that is my concentration of S8, assuming that each of these little circles is an S8. Now, if I was to add more S8, etc, 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 have I actually changed the concentration of the S8? Is there any more circles inside that pink box? Well, no. And that's because when you add more S8, you don't really change the density of it because it's a solid. So as the density of the solids doesn't change, their concentration won't change. And therefore, we don't need to include it, and we shouldn't include it, in our Kc expression. In terms of the units for this expression, we have 8 terms on the top and 8 terms on the bottom. And I could draw out the moles per decimeters cubed. For the sake of brevity, we know that the 8 on the top are going to cancel the 8 on the bottom to leave us with nothing. But we're not going to write nothing, otherwise the examiner might think you've just not answered the question. So we are going to write exactly the words no units. And that lets the examiner know that you've given your answer. Now that might seem a little bit weird to have no units for Kc, but it actually happens all the time. If ever you have the same number of terms on the top of your expression as you do on the bottom, you're going to end up with no units. So rule number 1, do not include solids in your Kc expression because their concentration is effectively constant. Another thing to bear in mind, and it's the same reason, if you have aqueous solutions and D, let's say D is water, so I'm going to replace this with H2O, we will not include the concentration of the water in our Kc expression. And that's because if these other chemicals are aqueous, are dissolved in the water, if I start changing the conc of these, it's going to have a negligible effect on the concentration of the water. The conc of this water is effectively going to remain constant. So again, our Kc expression would not include water, so that will just be C aqueous over A aqueous, B aqueous. In terms of the units, we've got moles per decimeter cubed at the top, 2 moles per decimeter cubed at the bottom. So 1 at the top is going to cancel 1 at the bottom to leave the number 1. To flick these to the top of the fraction, we're going to reverse the sign of the power. So moles becomes moles to the -1, decimeters to the -3 becomes decimeters to the 3. And then very finally, usually we put the positive power first, like so. So rule number 1, don't include solids. Rule number 2, if your other chemicals are aqueous, we are not going to include water. And just a little thing about that, you can see here, rather than having aqueous chemicals, I now have liquid chemicals as well as my water. In this expression, we would include the concentration of the water. And that's because these other liquids can now dilute the water sufficiently to change its concentration. And so we would need to include the water if your other chemicals contain a liquid. Okay, and very, very finally, so third rule, don't include solids. First rule, don't include solids. Second rule, don't include water if your other chemicals are aqueous. The third rule is if you have a pure liquid, and what I mean by that is one of your chemicals is a liquid, but there are no other liquids, then we're not going to include the conc of that chemical either. So my Kc expression here would be C gas squared over B gas. We're not going to include the conc of this liquid as it's the only liquid in our equilibria. So why is that? It's exactly the same answer as for the solids or for water. It's because its concentration will effectively remain constant. Look, again, if I put my decimeter cube box here, bear in mind this is the only liquid. If I was to start adding more liquid, I must be adding more of A. And look, it's not going to change the number of moles of A in that decimeter cubed. And so we will not include that in our equilibria. In terms of units, we've got two terms on the top, one term on the bottom, cancel. So we'll just be left with moles per decimeter cubed. Don't include solids. Don't include water if everything else is aqueous, and don't include what we call pure liquids, where you've got an equilibria with only one liquid in.